It's my pleasure to introduce today's colloquium speaker, Shiva. Actually has an interesting story. He got his PhD from Stanford in 1999, and we attempted to recruit him to our department as a faculty member back then, but he chose to go and found a company called Gigabeat, online music company that was then acquired by Napster, and we all know what happened to Napster. But he went and joined Google, where he was working on a number of projects there, and now he's the director of the Kirkland Google site, which he just told me has over 200 employees, and also he's a distinguished entrepreneur at Google. So, welcome, Shiva.
Right. Thanks, Oren. It's great to be here. I'm going to talk today not about search, because I'm sure you've heard a number of talks on how Google does search. So today I'm going to talk about how we make money through the ad systems. And as it turns out, the complexities in building out the ad systems are actually pretty significant compared to even search, because the amount of data that's going through the advertising systems and the dynamic nature of the data is just pretty darn interesting in terms of computer science. So in the beginning, you've seen this picture. This is what google.stanford.edu looked like. A whole bunch of machines, and Larry and Sergey had bought a bunch of hard drives from the back of a truck and built out these machines. And then we have been working on a number of other products. We've been working on collaborative applications. We've been working on email, instant messaging, large systems, and of course, ads. So what I'm going to talk today about is the core of the ad system. What are the key ways in which advertising works? And some of this may be obvious to many of you, but I suspect that the distinction between pay-per impression, pay-per-call, pay-per-click, pay-per whatever are pretty interesting concepts, and how they map into the billions of dollars that we make in Google are pretty interesting.
Yeah, paper has a very different meaning at the university.
Paper, right. This is pay-per-something else. And I'm going to talk about the systems that are powering the ads backend in terms of how do we take this huge amount of data that we get and how dynamic they are, and how do they get to work across multiple data centers and so on. Finally, I'll be talking about Adsense, which is one of the products I used to work on. It's a contextual targeted product where we want to show ads on the entire web that are contextually related to ads on a given to the given page. And also, please stop me at any point in time and ask me questions. I'll be happy to answer them. I'll get really bored if I just go through my slides. So do stop me. Early on, about maybe 5 years back, this is what Google Ads looked like. We introduced the pay-per-impression model. This is back in the late 99, 2000 timeframe, when pretty much everybody on the web was buying up eyeballs and wanting to show advertisements on sites which had a lot of impressions. One of the key differences that Google had was it was still targeted. So rather than showing a completely random ad, like click on the monkey ad on google.com, which would have been a very bad experience for the user, we decided to hook it up to the actual keyword that the user was searching on. So in this case, the query is for rental. So we figured, why don't we start showing ads for rental as a keyword? And some of the most obvious ads were maybe rent.com in terms of searching for local apartments, or searching for perhaps buying a condo in the Seattle area. So this is what we initially launched a few years back. And this is what is called as a pay-per-impression model. So the advertiser comes and gives us money. Say they buy 1 million impressions and give us, say, $2 for every 1,000 impressions that we show. A couple of key properties that this model had was that it had to be sold by Google's advertising force. So we had a number of salespeople who used to call up perhaps rent.com or Procter & Gamble and say, okay, we have 1 million impressions of Tide that we want to sell. So how many of them do you want to buy? So there was a significant sales component to how we initially launched this. The other part of this was that for every keyword, there was an inventory management problem, because rental could be a very important keyword and would be desired by a number of different players. So inventory management was sort of an interesting problem in this space. But it turned out this was too small in terms of it wasn't going to make us a few $1 billion and we would have gone bankrupt, right? So that kind of was a problem. Then what we did was this was the second part in our evolution. We started selling ads on a per position model. So here what we said was, again, it's still on an impression basis. But rather than selling a single ad, we also had ad slots on the right-hand side of the page. So these were still relevant to what the user was looking for. And here what we said was, the top spot is very well desired, so you had to pay $15 for that. Or the second spot is $12, you still have to pay for that. And again, the model was on a pay per impression basis. And at this point, we moved from a purely our salespeople calling on people to a more of an online sales model, where we said any advertiser can come in and can buy these slots and pay the amount of money that we had to pay. So this was the next phase of our advertising product. Then came along Adwords, which is how we make a lot of money in Google right now. And this was a shift away from impressions to clicks. The model here is that if a user clicks on an ad, that's when the advertiser will end up paying Google for that particular ad slot. So this was sort of a pretty big shift back then. And still we had the idea of having the right-hand side slots as well as the top slots. And for the first time, we actually introduced the notion of an auction mechanism, whereby the advertisers could bid whatever they wanted to bid, and we would decide which ads would go in a pretty dynamic auction that runs all the time. And incidentally, by moving to the auction mechanism, we also simplified a whole bunch of problems around how do we manage inventory where you have a single set of slots, and how do you not sell the inventory to folks at a non-fair price, and either too much or too little. So anyone know who made this quote?
Henry Ford.
You did know that. So yeah. So the key here is that we did not build a product that the market was asking for, because the market at that point was asking for the pay-per impression and pay-per slot kind of model. And the switch away from something that the market is asking for to something that seemed a little radical back then was, it turned out to be a good decision for us, but it was not obvious when the decision was made. So any questions before I get into some of the key concepts behind auctioning and advertising? All right, no. So number of definitions. I'm going to keep using these definitions over the next few slides, so I want to make sure we understand these things. Most of these things are pretty obvious. Page inventory is the available slots on a per page basis. So we have page inventory at the top. There are maybe a couple of slots or maybe 3 slots or whatever the number of slots are, and then a number of slots on the sides. And there's no fixed number of slots that we need to have, because if there isn't any competition for those slots, then clearly we would not fill up those spots. But in the cases we do, we certainly have a maximum number of ads we have on a google.com search result page. Keywords are what people type in when they come to google.com. Green pencils. They come in and type in green pencils, and they want to see information about green pencils as well as ads about green pencils. Impression is when we show an ad to a user. Even though we are not charging on a per impression basis, we certainly map it, as I'll show in a few slides, to how often do we show an ad to a user, and we count money that way. Creative is the actual ad. So in the banner ad world, it's like an image. It could be the click on the monkey banner ad. But in the context of textual ads, which is what we run on google.com, these are a call to action saying, I want, buy green pencils here, or 10% off of green pencils. And there's a corresponding sort of calls to action with multiple lines per creative, and the keywords that actually are are the required targeting criteria for that particular search query. CPM, unlike people, so CPM is cost per mil, which is actually 1,000 impressions. It's not cost per million. That's a common mistake that a lot of people make. Anything that we do in terms of optimization we run in the ad systems, we usually look at what is the delta, how does the CPM change if we make a change to how we do targeting versus another way of doing the same targeting. CPC is cost per click. This is the amount of money that the advertisers are willing to pay on a per click basis. Could be 30 cents, could be $15, depending on how much the click is valued at by the advertiser. For example, a lawyer who wants to sue people for maybe a class action lawsuit on mesothelioma would be paying maybe $10. So there's a pretty wide range in terms of how much a click is valued by the advertiser. And we don't care about the actual prices. The prices are set by the advertiser.
So are those really the cost of prices? I mean, is that a cost for what it costs you to produce 1,000 impressions, or is that a price for what you charge someone in order to get it?
So the question is the CPM, is that the cost that it takes Google to generate an ad? Or is it the amount of money that we make on 1,000 impressions? It's the latter. The cost per impression that we have is a pretty complicated function, because we had to also serve the google.com ads, and there's the google.com search results, and there's a lot of crawling and indexing and search quality that goes into a lot of those things. CPM over here, I mean that when we show an ad, how much money do we expect it to make? The other way of thinking about this is RPM, which is the revenue per million. But CPM is the industry standard, so we use that. CTR is the click-through rate. How often on a given query would a person click on an ad, and that is the corresponding click-through rate. Here's an ad. So you can go to adwords.google.com, and you can sell whatever you want to sell. In this case, let's say we want to sell a Seattle penthouse, for example. And here there's a whole bunch of descriptions within that. It's a 2-bed, 2-bath in a fantastic location and has views of the mountain. And what the advertiser wants to do in this case is to go and create a number of keywords. So the keywords that we have are Seattle apartment, Seattle condo, and here the advertiser is willing to bet $1 for every click that the person is going to get. So the advertiser has a model of how much these ads are worth to him, and so has figured out that I'm willing to pay $1 on a per click basis. You can look at historically what has happened. He's gotten 125 clicks over 5,000 impressions. So 5,000 times this ad has been shown on google.com, out of which 125 times this ad was clicked on. And we'll get to the average CPC, because this concept over here is the max CPC. This is the maximum amount of money the advertiser is willing to pay. But this is, in fact, we end up charging the advertiser a lot less based on an auction that I'll talk about in a couple of slides. So this is what the advertiser does. They come in, they want to create creatives for a variety of things that they want to sell. It could be your house, it could be a boat, it could be your hat. And they have a model of how much they want to spend on a per click basis, and they bet on that, and it shows them on google.com. Question?
Do you attempt to define words by their semantic meaning? Say I want to buy the word window. Is there a way for Google to tell if I search for window of opportunity versus a window covering, which window I meant and when I purchased the ad?
So the question is about how do we take into account the context of a given word. I'll actually talk about that in a subsequent slide. But at this point, think of this as a very simple concept. The advertiser has come in and has said that I want to target on a window, and I want to show my ad for that. And there is disambiguation that we can make recommendations on in terms of what are the different connotations of a given word. I'll actually even show a demo towards the end of the talk. So the process of creating an ad is very, very straightforward. And this is quite different than how it used to be, like a few years back, because you had the notion of agencies that would make ads for you, and they would have to worry about where the ads was going to be placed. And by making it all self-service, we made the advertising industry a lot easier to work with. So now let's talk about what goes on when an ad needs to be displayed on a google.com search result. In a way, this is a specialized search. In the typical search case, what we do is we have many billions of documents that we have crawled from the web, and we want to, given a certain query, we would want to figure out the best sort of documents that we want to show to the user. And this is done by classic IR and a whole bunch of other signals that you must have heard about in previous talks. We have the same kind of problem in here as well. Now, the reason why this is different is because the number of advertisers is much smaller. It's probably a few 100,000 advertisers. But beyond that, the actual data is very dynamic because they would like to change their bids, they would like to change their creatives, the keywords on which they target. So it's a much more dynamic system even though the data is much smaller. So in terms of complexity, this turns out to be a lot bigger. The other sort of point here is when a query comes in, we need to figure out what is the utility of the ad to the different parties over here. There are 3 different parties playing here. One is the user. We want to make sure that the user's interest comes first, because if we start showing completely irrelevant ads to a person who comes to google.com, then they'll be turned off. So we want to make sure that we give relevant ads to the given query. So that's one critical part of the equation. Second critical part is we want to make sure that the advertiser can truly bid whatever they want to bid. How much ever is the value of a click to them is what they need to model into how much they're willing to pay on a search result. And the third part of it is us. We want to make sure that we are making enough money as well so we can power our google.com search, the rest of the products that we keep developing. So we need to balance the high click-through rate of a given ad, because that implicitly tells us that the end user who's searching is interested in this particular ad, along with the advertiser's willingness to pay. So that's really what we need to model in terms of how we do the auction. So as it turns out, auction theory, which has been around for many, many years, is something that we can tap into for deciding how do we show the best set of ads to a given query, as opposed to using information retrieval or the other ways of doing search. Here's a couple of examples. These are 2 different ads for the same query. Yeah?
So what happens if you get a search with no ads or very few ads actually related to that search query? Do you sort of expand, because you said you're concerned with the relevance of the ads to the user's query, do you broaden the scope of the ad search query and risk, bringing less targeted ads, or do you just
So the question is, do we broaden the scope of our ads if there aren't enough ads for a given search query? There are a few variations that we do. For example, there are 2 different answers to this. One is on google.com. Clearly, there are synonym-based expansions that you could do. Or perhaps in some other cases, you can do stemming to increase the scope of ads. But in all these cases, what we do is we tell the advertiser, hey, here are some other keywords, and I'll have a demo of that later. And let the advertiser pick based on what they would like. In a number of cases, it turns out that the query hotel versus hotels end up having different behavior from the end user. We don't know why, but it does. And the second answer is, I'll be talking about Adsense, which is our contextual targeting product, where we have pages on the web rather than search queries. And in that case, we do a number of things to expand the scope of ads, because that's pretty much required for the problems we need to solve in that space. So a couple of ads. So let's say that skydiving is a concept that people want to advertise on. 2 completely different markets. So one is a company that wants you to come and skydive with them. The other one is insurance, which also is a perfectly legitimate ad for that particular concept. So now the question is, which ad would you show, because we have the top slots to fill up, or we have the right-hand sides to fill up. And we want to make sure that these ads are relevant to what the user is actually trying to search on. Here are a couple of examples. In one case, the advertiser is willing to pay 40 cents, and here they're willing to pay 20 cents. And in this case, the CTR is 2%, and here the CTR is 5%. So now the question is, which ad would you want to show? So what we do is, this is where the CPM concepts come into play. We do effective CPM, which is just the expected amount of money we're going to make on that particular impression. And here we have the effective CPM equal to $8, and here we have the effective CPM equal to $10. So what we would end up doing is we would end up choosing the ad that has the higher effective CPM. That's really how the auctioning works. Yes?
When you speak of the click-through rate of a particular ad, is that within the particular context of this search or globally?
Right. So the question is the click-through rate, is that for a given specific keyword? The answer is yes. And in fact, I'll be talking, there are a few more parameterizations. In a few cases, the click-through rate on a given ad from a certain country will be different than click-through rate on the same criteria from a different other country, or time of day is another metric as well. So the number of dimensions that you would use for using historical click-through rates and predicting how CTRs change over time.
So isn't actually one of the key dimensions where the ad is? I mean, the calculation that you described is a simplification to the correct one.
Yeah. So I made the point that I'm sort of like simplifying a whole bunch of things that I'm talking about. But I'll add a few more dimensions in a few slides. For example, position is key. You're influencing how much an ad is going to be clicked on by placing it at the very top spot, because people's eyes tend to go to the top right-hand corner. Right? So there are a number of things we need to do to fix it up. Yeah?
How do you predict the click-through rate for an ad before you started showing it?
It's a great question. And I'll briefly talk about some of the challenges over there. But yeah, that's one of the problems that we need to worry about.
Clearly, advertisers are in competition with each other in this auction. Are they in competition with Google in any way?
The question is, the advertisers are in competition with each other. Are they in competition with Google?
Or a friend to the advertisers?
So the question is, how much do we pay? How much do we get out of this auction? So this slide would hopefully answer your question. The 40 cents that the one company wanted to pay and 20 cents the other company wanted to pay are the true value of how much they perceive that click, and it depending on how much conversion they end up getting in terms of once they click on an ad, do they end up buying a service from them or not. So they've reflected that into their CPC that they've made up. But you notice that the effective CPM we got on one of the ads, let me go back, was $8, and then the effective CPM on the other ad was $10. But, and so because of that, we decided that number one was actually going to be higher ranked than the second one. But if the top placed ad had ended up bidding only $8.05, they would have still won the auction, right? Because they don't need to have paid $10 worth of effective CPM to Google. So this is sort of a problem. So what we end up doing is we act as if they did only charge a little bit more. So what we end up asking the advertiser to pay is only 16 cents per click, not 20 cents per click. So effectively, this is what is called as a second price auction, and this is one of many ways to do an auction. So in terms of whether Google is an adversary in this case or not, what we want to do is we want to build up an efficient auctioning system where the advertiser bids their true value, and the system acts in the best interest of the advertiser from a cost that they pay standpoint. Click-through rate, we still want to make sure that the users sort of dominate in that case. But the amount of money that the advertiser pays for us, it's in our interest to make sure that in the longer term they are only giving us accurate data about how much they're going to bid. When there's no competition, let's say that you have a very exotic product you want to sell, and let's say you only want to target green pencils that have a Mickey Mouse logo on it, and that could be that could be the company that you have. So in that case, if there's no one else bidding for that particular slot, then you end up paying the minimum, which is only 5 cents, which is a great way to sort of get your ads onto Google. And given that there's enough inventory of keywords coming into Google, it just keeps that long tail keeps growing. And again, just to summarize the point I was making earlier, the quality of the ad is still very paramount, because the users will not be happy if they start seeing very, very broad ads. So we want to make sure that is reflected in how we show the ads. And so in a number of cases, if you notice that the click-through rate is below certain thresholds, we would stop showing the ad, independent of how much the advertiser is willing to pay. And also, the amount of money that the advertiser is paying is as close to how much they really value the bid. Actually, it's going to be lower than how much they really value a bid. So let's go in just a little bit into auction theory. Any questions before we get to this? All right. So the flavor of what I just talked about is going to be more obvious if you look at how the dynamics sort of work out in this case. So number of auctions that we've had in the past. The English version was the going, gone, where you start at a certain minimum price, and then you have multiple bidders who start saying, okay, I'm going to bid an extra $10 for that item. And it keeps going on until there's no more bidders working on that auction. Dutch had a different way of doing things. They kept dropping the price until someone bites. So you start at a certain high value, and then you keep lowering the overall price until someone bid. Again, a lot of these things assume that it's a uniform price auction. The value of the good that you're bidding on is roughly the same for everybody. If you're buying an artwork, then this doesn't really make sense, because then the bidding patterns and how people the actual way in which people bid differs on their perceived value, which is quite different. So in all these cases, we're assuming that the value is roughly the same for all the people who are bidding for that product. First price sealed is typical in silent auctions. So you have a piece of artwork, and rather than going through the charade of having multiple people raising their paddles, you ask them to write the amount of money they're willing to pay into a sealed envelope, and you pick the best price for the good. The problem with a lot of these things is what is commonly called as a winner's curse. So speaking about the uniform price auction, where everyone should really value the commodity in a similar way. If you take a number of bidders, the average that the group is willing to bid is probably closest to the real value of that commodity, right? So the problem is that the winner is clearly winning by paying a lot more than the average. So this is kind of a problem, because a few years back, a number of oil companies used to bid for drilling rights in pick a new oil field that comes online, and the average bid might be $10 million, and which is probably reflective of what the true value is. But a lot of them ended up paying, they wanted the oil field, so they ended up paying like $15 million. So people got smarter quickly, and they realized that they were overbidding. So they started lowering their bids, and this is commonly called as bid shading. And this complicates how the advertiser has to decide how to select a bid. So in all these cases, we have a problem. If we build a product which people don't know how to use, in terms of not being able to figure out that they need to bid 30 cents for a certain commodity, then we have a problem. So we don't want to get into that game. This has been studied a lot in economics. So Vickrey Auction is a pretty well-known auction, and the model here is that the second price sealed. So you have a number of blind auctions that are going on effectively, and what you end up doing is you end up picking the second highest bid as what the winner ends up paying. And he proved that it has the simplest bidding strategy, just bid your true value, And it all sort of works out. And he won the Nobel Prize for this observation. So realize that a few slides back, I essentially just talked about this. When you have the $8 eCPM and the $10 eCPM, we end up charging the advertiser, the winning advertiser, only the second eCPM rather than the first eCPM. So this is partly how we get past some of the bidding problems. So I'm going to start talking about the systems that power the ads backend. So now that we know roughly how the auctioning process works, one of the questions that came up is, how do you predict the CTR? We do not know, in our calculation to compute the effective CPM, the CPC is something that we just talked about. How much we charge to the end, to the advertiser is roughly just what the previous bid was. But another complex problem over here is, what is the CTR that you think a given criteria creative, which is the ad, actually has, so that you can end up maximizing the eCPM. If the actual CTR prediction is off, then the auctioning parameters get thrown to a tizzy as well. And it's much more complicated than just predicting a CTR of a given ad, because it depends on a country, it depends on the actual query, it depends on time of day, lots of different dimensions. So one of the problems that we have constantly is, how do you update the model? So one way computationally you can think of how we can do this is to look at historical data. So imagine having a very, very fast system that takes into account how the ads for a given advertiser are performing, or for a given concept are performing, and reflect the behavior of what the users are doing very quickly through a very, very fast system, and model based on what has happened historically, and predict in the future that the likely CTR with a certain confidence interval is 2% for this particular creative. So the number of challenges going into building a system like that from a systems building standpoint as well as from a prediction standpoint, so we invest a lot of work in that. And also, how do you estimate the CTR for a not yet shown ad? This is another hard problem, because if you have an ad that comes in that's never been shown before, then what do you expect as a CTR? So a number of possible solutions. One is you can go with the base CTR, and given a certain criteria, a query, say that this on average is about 3%, and on average is 0.5%, and start with an initial model and refine it quickly. Or you could sort of say that the click-through rate on a given country is 1% because people don't like to click on ads, or during the day people don't like to click on ads because they're at work. So take a whole bunch of dimensions like that, and you could model an initial approximation, and then you can refine the predictions over time. And the interesting part is that every single one of these things is purely experimental. You have an initial idea as to what is a good way of estimating some of these different numbers, and as you refine these numbers, the amount of money we are making, or the end user quality, or the amount of money the advertiser ends up spending all changes quite dramatically. This is why this is a cool system. You can try it out and see what happens, and then change your behavior and change your algorithm based on different estimation techniques. The other part of the system is that the advertisers are spending a lot of money in this system, so they want to know what is going on very, very quickly. Now think about how search works. Search is much less dynamic in that you can crawl the web for, K number of weeks, months, then pre-compute all the indices you want to, and then you want to push it to multiple data centers in different countries, different geographical areas, so the end user query is a lot faster. Similarly, in the case of ads, we would want to necessarily be close to where the search queries are coming in from, so we can serve our ads very quickly as well. So now you have a number of data centers, a number of machines across lots of geographical areas. And now you want to solve the problem of, how do I count my clicks? How do I compute my impressions in a global distributed fashion so that I can accurately predict how the auction is going to play out. So these are some of the challenges that we have to solve, which are much more complex because of the dynamic nature and the real-time nature of the ads that are of the data we need to process. Also, they would like to know how the advertisers would like to know how are my advertisements performing in a given country or in a given time of day. So computing all that is hard because you cannot really use traditional databases to solve the number of reads and writes we need to process. We've looked at commercial databases, and they don't scale for the number of reads and writes that we have had to process. Or if they scale, then they are way too expensive. So one of the decisions we made early on was to use MySQL because it's free, so you can't argue with the price. And it also is, you have the code to work with, so you could go and modify the code to do special things for you. You can change the backend storage if you wanted to. You can use the MySQL parser if you wanted to, the query engine if you wanted to. So what we do is we take all the customers that we have and we shard or we partition all our customers into several different database servers. And also we clone them to make sure that we have enough reliability and we have enough throughput. So we want to make sure the advertiser can come in and change their campaigns very quickly. We want to make sure that we are serving all the ads that we need to serve very, very quickly so that the end user is not suffering through that. So this model of having partitioned data across multiple databases and replicating them like crazy is how the system has evolved. Along the way, we had to build up our own languages because we wanted to make sure that from an engineering standpoint, we could modify the schema, we could modify how we render the content onto front-end servers, blah, 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 so that we could, so we had to invent a new language along the way. So this is just another flavor of things that we had to do. Building large systems, building up new languages, building up how we modify the schema, and all these sort of are core components of how we end up scaling the ad system. There's a question there.
Yeah, to manage the cluster, do you use MySQL or do you have your own solution to manage that cluster?
The question is if to manage a cluster?
Cluster of database that you talked about just before, do you use MySQL itself? I don't know much about MySQL. I'm just asking you, like, do you use some feature in MySQL to manage the cluster or do you have your own solution?
Right. So there's another talk that Michael is going to give in a little while. Michael is there. Wave your hand. So we have built up a number of other parts of our stack in, this is how we run all our applications. We have a number of machine management mechanisms. We have a number of file copying mechanisms. We have our own distributed file system. We have a number of systems we have built up that we reuse for some of the backups, for some of the recovery, the snapshotting, transactions, that also apply in how we do the ad system. But ads is different, again, from the search systems in that there the data is all very static relatively, and this is much more dynamic. So the solutions that we have are different, which is what I want to get across in this part of the talk. Okay? So I'm going to switch to contextually targeted ads. So until now, the problem has been interesting in that you have a query that comes into Google, green balls, and we want to show ads related to that particular sort of to that particular keyword, and it's a lookup. You go look it up, and then you figure out from the auction which is the best ad to show given a number of ads that you want to work with, and you have a whole bunch of systems that you have built up that figure out how to predict CTR, how to move the data very, very quickly across multiple data centers, and so on. This set of problems has the same flavor of issues, but it's quite different. Here, we do not have a query. So we launched the Adsense product about a few years back. And the goal here was, how do we show contextually related ads to any page on the web? So if the page is about cheese.com, then you would want to show ads about cheese. the page is about digital cameras and you want to show ads about Nikon D70 and your Canon as well as other generic digital cameras. So this is a different problem because there's no keyword that we can use to figure out what ads to show. So in this case, we have cheese, and we have some recipes. We have lose 20 pounds in 3 weeks, and we have some English cheddar and a number of other things. So all this is, you must have seen, how many of you have seen these ads by Google on all kinds of pages? So a number of you. So here the problem is we do not know what to show on the page. So it's a contextual targeting problem given some content. Adsense for content is the same, the product I was just talking about, is the same as the Adwords in that we're still using the Adwords advertisers. We had built up a large number of Adwords advertisers who had come in and said, we want to show ads on digital cameras, or we want to show ads on green pencils. They're still the same set of advertisers. Ranking is still done based on an expected CPM. And the second price auction, all the things we talked about in terms of how the auctioning works still works the same way. But the problem that is different here is it's not a simple lookup. Here, it's not a matter of getting a query from google.com and going and looking up a table and saying, okay, these are the candidate ads that would likely want to show on this page. Here, the publisher, this could be Slashdot, and they could have a new article about digital cameras. So the publisher gives us the inventory, and based on the target URL, which is slashdot.org/camera00135.html, we have to figure out what we have to quickly crawl the page, figure out what the page is about, and then show ads that are most relevant to that particular page. And here we share the revenue with the publisher. In case of google.com, it's our property, so we keep the money. Here, the publisher is doing a lot of the work by getting the inventory on their side. So we want to make sure that we share the revenue with them. And also, we have a lot more new formats and new media types. For example, we have images, we have flash ads, because that's what the publishers want. So this is the $1 billion JavaScript snippet. This is what the publishers put on their site. It's a very simple bit of JavaScript. So they specify the width of the ad. In this case, it's 728. And 728 by 90 is considered to be a simple, very specific creative size. And then they can say that I want a text image. And all they do is they just source in this JavaScript, which is hosted on googlesyndication.com. And what it does is pretty straightforward. It tries to figure out the number of parameters that automatically get filled in, and we end up showing an ad on essentially an iframe. So imagine on the top of a page, there's an iframe request that points to our backend servers, and we get along the way the document.url or the document.refer, which tells us what the page is, the URL of the page, or the referring URL of the page. And based on that, we can either go quickly crawl, or in a number of cases, we also have the google.com crawler, which may have already crawled the page. So we just go quickly look it up, and then we go and figure out what the page is about. Now, the second part is pretty interesting in terms of how do we figure out what the page is about. So I'll get to those slides. In the publisher network, we have launched a number of different kinds of different kinds of ad formats. So image ads, audio ads, click-to-call ads. So here is actually a case where we have a little telephonic icon, and you can click on that, and the user can end up calling the advertiser. So this is one of the things that we launched out of the Kirkland office across the street. And video ads. So number of ways that we can show advertisements on a publisher page that is, again, contextually relevant to the page, and gives the advertiser different options through which they can decide what they want to expose to the user. We talked about different models. In the AdWords case, we went from a CPM model, the cost per impression model, to a cost per click model over time. But in the Adsense network, the large number of publishers who show these ads, they prefer to decide how they want to get paid. In the case of pay per impression, they don't take any risk. They just get paid whenever we serve 1,000 impressions. In the cost per click model, there's more sort of hand that they have. They have more of an incentive to take a bit more risk, but the rewards could be higher as well. So there are some interesting challenges in that space. So in terms of we talked about, we know what the page is now based on the document.url, and we have the actual content of the page. So now how do we figure out automatically that the page is about cheese or about digital cameras? So we need to understand what the page is about and also define the best matching ads. And how do you even define a best match? Because in the case of cheese, there are different ads you could have shown. You could have shown an ad about cheese recipes, or about English cheddar cheese, or about losing 20 pounds in 30 days. Also, there are some restrictions. There are some business restrictions that you don't want to show a competitor's ad. If it's a site that is selling DSL services, then you don't want to show an ad for another service provider. And this is all done very, very, very much. I mean, a lot of times in a given day. So all this has to happen within a few milliseconds, because the end user is not going to wait for us to choose the best ad. So when a request comes in, an iframe request comes in, we got to figure out within some tens of milliseconds what the page is about and show the ad back to the user. This is where some of the challenges come in. In Adwords, I talked about how we use MySQL databases to partition our data. Adsense, on the other hand, is actually slightly more, is less databasey. It's a lot of reusing of the stack in terms of, we want to take a lot of data about the pages and about how queries get to pages and a number of other signals, and figure out what are the key concepts behind given pages. So we use our usual classic GFS, which is our Google file system, and a number of the partitioning mechanisms we built up to analyze large amounts of data pretty quickly. But I'm not going to spend too much time on that. So how does the analysis of a page work? The classic observation that people had is that if you have a lot more sort of computational power, you can solve very hard problems. The problem that we are solving is actually different. It's more about the data. If there is a lot more data that we have, either through search queries or through web pages, then our claim is that you can actually solve very hard problems. And this is one of the key insights into how Adsense works. Here's an example. How do you define similarity between Kofi Annan and the UN Secretary General? Clearly, they're the same person. But from a classic TF IDF perspective, the metric, the cosine between the two is 0, because there's no matching between the two. So just to sort of quickly go over TF IDF, TF is the frequency of the term in a given document or query. So just counting up the number of terms in a doc. IDF is the intuition behind this is that if a word is too popular, then pretty much just discard, is what the IDF, it's the inverse document frequency. This is term frequency, this is inverse document frequency. TF IDF is just, is a cosine between TF and the IDF. So I think the next slide is some examples. To a human, most of these things are exactly the same. AI, artificial intelligence, Eric Schmidt, Google CEO, Larry Page, Google founder. But the classic TF IDF mechanisms will say that the overlap between these two is 0, because they look nothing like each other. But this is essentially the problem we need to solve in Adsense, because the pages themselves may not necessarily have all the terms that the advertiser is talking about. It may have different terms. It may have related terms. It may be talking about Canon D70s, but may not use the word digital cameras in any of the given text. But do you want to show an ad that has something to do with Nikons? Probably. So this is part of the motivation behind how do you start looking at combining, how do you start looking at overlap between different textual elements? And the inverse also applies. Larry Page, web page have nothing to do with each other. So the metric that you want to use to compute the similarity between two pieces of text should split off the possibilities so that the ones that are closely related should be greater than some threshold, and the ones that have nothing to do with each other should be below some threshold, conceptually. What we do is, this is one way of coming up with a metric, and there are a number of other ways. I'm just going to walk through a simple example of how we could solve the Adsense query overlap problem. We have to use a lot more contextual meaning. That's really what we need to do. So what we do is we want to take if given a short text snippet, we want to make sure that we can expand it to other related concepts as well. So this is sort of similar to how query expansion works in IR. So let's walk through a way in which we could do this. So let x and y be two short text snippets. And we want to define a function that measures the semantic similarity between x and y. One approach for doing this is to define the query expansion as follows. Take x and send that as a query to, say, a search engine like Google, and get back a whole bunch of documents. So now the word artificial intelligence would have been the key query. Send it off to Google, and it comes back with, say, 20 results. You can take each of those documents as your result set, and you can start defining the QE of x to be the average of all the vectors. So essentially, for every DFID vector that you have for a given result document, you can say that my query expansion of x, which is the keyword that I sent out, is essentially the average of all the DFID vectors across all the documents. And you can define the similarity between x and y, the words that the two text snippets that we want to find the similarity between, to be q of e dot q of y. Here's the example again that we talked about a little while back. So the cosine metric that we talked about, the TF-IDF measure, clearly has a value of 0 for all these different cases. And in this implementation of the query expansion, the numbers look a lot more reasonable. So Larry Page has a f of x comma y of 0.123. I'm actually skipping over a bunch of details, but the point is that with that metric, you could have enough of a spread between the ones that are close to you and the ones that are far away from you. And clearly, there are a number of other ways in which you can do this. The better job you do of splitting off these things and making the textual snippets be similar or dissimilar, the better ads we end up showing to the user. So this is what we keep thinking about: how to improve the different metrics. How do we keep building up new metrics, and also how do we pre-compute as much as we can so that when a request comes in from an end user, it's very, very fast. It has to be done within a few tens of milliseconds. The inverse problem, as I was talking about earlier, is how do you sort of handle different contexts for the same word Java. So Java Indonesia, clearly again, the cosines are meaningless in this case. But you can see that there is, based on at least the algorithm that I showed in the previous slide, there is a pretty good sort of spread between where the scores end up lying. So my last slide was about the Kirkland office that we have across the water. We have launched a bunch of things. A number of them have been in ads, a number of them have been in search quality and other areas as well. So we've had a number of projects on AdWords optimizations that have added a lot of money to the company. Simple ideas that where you improve the metric that you use, or simple ideas that end up speeding up some computation, end up adding a huge amount of leverage to the company. Adsense quality is another area. Analytics, click-to-call ads, where you click on a little icon, we end up having people talk to each other. We have a number of things in search, where we have indexing, sitemaps, webmaster console, a number of consumer products. We have a lot of work going on in Google Maps, Talk, Google Video, Google Pack. So a number of things are happening in the Seattle Kirkland operation. So if you have any questions, you can find me, or I'll take any more.
Just one question. You were talking about how the auction process or the ad process is very dynamic. The input is very dynamic. Certainly, the input in terms of click-through rate, it changes all the time. But to advertisers can advertisers change their bids on a very frequent manner?
Right, so the question is, do advertisers end up changing their bids on a regular basis? Yes, they do, which is why we need to have a very dynamic system that reflects all the changes they do, not just from a changing the bid standpoint, but they end up changing the creatives that they want to show. They want to end up changing the list of keywords on which they want to show their.
That's something that a person, sits and, every day the ad guy at the store, the owner does it, whatever. But I'm talking about, are there advertisers that have, first of all, does the advertiser get feedback on how often they missed an auction? Stuff like that, and if so, do they have an API or something to allow them to respond or something like that to change things a little more?
Right. So we certainly have an API, and a number of companies use that to change. We have this quick feedback loop whereby we tell them how many auctions do they win and how many clicks do they get, and based on that and how much money they want to spend, they want to certainly refine how they play with the system. So that happens a lot. So that's why building a truly dynamic system that handles to the scale is where the complexity really is.